Hello everybody. Today I'm going to be evaluating this integral from 0 to infinity of sine squared x over x squared. And this looks a heck of a lot similar to a very famous integral, which is the same bounds, 0 to infinity, of the whole thing not squared. So sine x over x dx. And obviously this isn't what the video is about, um, but this is equal to pi over 2. And I'm just mentioning this because I'll have to use this result to evaluate this integral. And there's many great videos on this one right here. I'm not going to bother with linking them. You can just look it up. So, but our main focus is going to be this integral right here. So, what we're going to do first is change sine squared x using the cosine double angle identity, or sometimes in this direction it's called the power reduction formula, I believe. I've never really called it like that. But it really stems from the cosine double angle identity because, so here we have cosine of 2x, and we can write it cosine of 2x as 1 minus 2 sine squared of x. So we can solve for sine squared x in terms of cosine of 2x, right? And this is used a lot because cosine, just a normal cosine's integrable, but sine squared is not easily integrable. And so our integral becomes from 0 to infinity, and I can pull this 1/2 out here. I get 1/2, and I get 1 minus cosine of 2x, oops, 2x over x squared dx. And what I'm going to do, and this might seem very non-intuitive, is if I rewrite this 1, okay, if I rewrite this 1 as a cosine of 0x, so now I have, and the justification is because cosine of 0 is 0, and 0 times x is 0. So it's the same thing. It's just I've rewritten 1. You might be wondering, like, why, what is the point of that? But now, if we notice, we have sort of the same function, right, being subtracted, okay, cosine 0x minus cosine 2x, and, well, the nice thing about that is that this is what a definite integral looks like, right? This looks like some sort of definite integral. In particular, what we can do is, so I still have this 1/2, and then the integral, and if I pull out a 1 over x, right? So now I'm just going to consider, if I have a 1 over x here, if I just consider this expression right here, then is actually equal to the integral from 0 to 2 of sine of tx dt. Because when I integrate this, so x will just be a constant. So when I integrate this, I get negative cosine of tx over x. And when I plug in my bounds, so the negative cosine will make the 0 term the positive one, and the 2 one will be negative. So I've rewritten this whole expression in terms of another integral. And what we can do now is, so this was our original 0 to infinity. This 1 over x is a constant with regards to the dt. So I could pull it in right here. And then I swap the order of integration. Or I don't have to rewrite the integral, but so now I have this dx integral. So the x integral is now on the inside, and we can focus on it now. So if we notice, we're integrating sort of like the same function that we had before, except now it's from like 0 to infinity, so it's easier to integrate, right? Because we know if we look at this form, it looks a lot like this integral. And all we have to do to make it the same is multiply by a t on the bottom and the top. Because if I said, okay, let u equal to t times x, okay, u equals tx, then this becomes a u, this becomes a u, and this becomes a du. And my bounds stay the same, because if x is 0, no matter what t is, then u will be 0. And if x is infinity, no matter what t is, u will be infinity. So that tells us that this entire integral is just pi over 2. In other words, our result, the original integral we were trying to find, is the integral, or 1/2 the integral from 0 to 2 of pi over 2 dt, of course. It doesn't really matter now. And this is just a constant. So the integral of a constant is just the constant times the length of the bounds, which is 2. So I get 2 times 1/2, which cancel each other out. So these cancel each other out. And essentially we're just left with pi over 2. And that is the answer to this integral. The integral from 0 to infinity of sine squared x over x squared is equal to the integral from 0 to infinity of sine x over x, which is equal to pi over 2. So I think that's just amazing and fabulous. Um, so anyway, thank you for watching, and I hope to see you in my other videos.